Hello, this is me with my vacuum tube Tesla coil. I guess we'll start over here. This is my plate transformer. It is 3 kVA. There's, I believe, 3.5 gallons of mineral oil inside this bucket. The reason I made this was a friend basically explained to me that I really shouldn't have to buy a really large plate transformer if I can just put the one I have in a bunch of oil. And turns out that does a very good job, and it'll handle 10 kVA continuous without any issues whatsoever. It works really extremely well. I use this high voltage bushing that actually came off of a pole pig, and this one obviously didn't come from a utility pole, so its name is the floor pig. So yeah, there's the plate transformer. Then the power comes through here for these little insulators, and it'll go underneath through there, and it'll go into my doubler capacitors, which there's 5 microfarads worth. It's quite a bit. There's a bunch of them. There's some right there. And turns out they have to be rated for the peak voltage, or else there will be an issue. Because what will happen is this will happen, and you don't like that, because this capacitor was only rated for 5,000 volts, and turns out a peak of 13,400 volts will do that. So we move on to the other side, where we will see our doubler diodes inside this box here. Again, there's more mineral oil in there. They're rated for 40,000 volts and 8 amps. Yep, there they are. Power comes up through this wire, which, by the way, high voltage cable is pretty expensive. So what I like to do is I like to buy the silicone tubing, put some regular 600 volt silicone wire in there, and it seems to have no problem holding off whatever voltage the system is operating at, which is probably around 15 to 16 kilovolts at absolute max. So then we have our nice resonant capacitors right here. They're 500 picofarads a piece, rated for 200 kVars each, right? We have this nice choke coil that I made today. It works very nicely. I like it. It looks awesome. Then we have, of course, the main thing of the show, which is the tube itself, which is a Gu-5b Soviet tube. It was made in '88, and it is rated for 3.5 kilowatts of power output. And in a minute, I will show you that I don't think 3.5 kilowatts is really what this tube is capable of, because I'm pretty sure it could do 3.5 kilowatts while laying on the concrete floor with no cooling. Because with sufficient air cooling, like this fan down there, by the way, which is a furnace fan, it puts out 600 cubic feet per minute of air. So I guess that contributes to this thing's performance. It will do 5 times that without any issues of overheating. Then we have our coils themselves right here. They're connected through here. These connections, some of them are a little bit, a little bit sketchy there, but it's all right. It works. We have our primary coil, which has some taps on it that I made. Then we have the feedback coil up here, which is 12 gauge solid, around 12 turns on there, connected with zip ties I drilled through. Oh, and the primary coil, by the way, is 6 gauge, and there's 35 turns on there. It's tapped on turn 33 right now. So yep. Another thing I want to show you is a few of the coils that I've made for this system in the past. Here is the original secondary I made for it. That right there is what happens when we have overcoupling with these things. And you can see what happened here. This would sit in here, and that's basically the situation there. It was pretty bad. But that's what happens with overcoupling. Also, this thing was very badly detuned, so this is what happens. when you mess up like that. Also, here's another secondary I made. It's pretty cool because I use these wooden dowels that I got to cool the secondary, because I had some problems with overheating secondaries, which really more of anything was from my wire being too small and, you know, bad tuning. Anyway, the other thing I wanted to talk about is the grid leak, which I've had more problems with this thing than anything else, because basically I had a situation very recently where I would walk in circles for about 4 days and I didn't know what the problem was. Turns out this light bulb here, which I was using as my grid resistor, was the problem, because I had incorrectly assumed that using a larger wattage bulb would mean that, well, for a bigger tube, I thought, because what had happened was I saw schematics with, you know, the Gu-81M, for example, where they use a 100-watt bulb in you know, the grid leak, and that worked for them. So I incorrectly assumed that a 200-watt bulb with a Gu-5b would be better. Turns out that's not the case, because the Gu-5b needs more driving power, and that assumption had me walking in circles for days. So basically just, I have a resistor now. I have a better resistor coming in the mail. It's pretty bad right now, but it works. One more thing. Here's the tube filament glowing. It looks really beautiful in there. There's, you know, the writing on the glass. And yeah, the filament takes 12.6 volts at 30 amps. And really glows quite nicely. Anyway, you will see the thing running in just a second.